Australia sits at the center of an expansive maritime region, anchored between the Indian and the Pacific Oceans. For a nation with a modest standing army and vast maritime approaches, defense strategy relies heavily on the ability to project force, secure sea lines of communication, and assist neighboring island states during regional crisis. The Royal Australian Navy's two Canberra-class landing helicopter dock vessels, HMAS Canberra and Adelaide, serve as the foundation of this strategy. They provide the Australian Defence Force, or ADF, with a flexible sea-basing platform capable of conducting amphibious warfare, disaster relief, and expeditionary power projection across thousands of kilometers of ocean. The decision to procure these massive vessels was shaped by operational lessons learned in the late 1990s. In 1999, Australia led the international force East Timor to restore stability to East Timor. The deployment was a strategic success, but it exposed severe limitations in Australia's maritime logistics and amphibious lift capacity. At the time, the Royal Australian Navy relied on HMAS Tobruk, an aging heavy landing ship, alongside two modified former United States Navy amphibious transports, the Canberra and the Manura. These vessels lacked the speed, capacity, and aviation facilities needed to insert and sustain a modern, combined arms military force on short notice. The ADF realized that relying on improvised sea lift created operational vulnerabilities in Australia's immediate neighborhood. To solve this gap, defense planners evaluated the concept of landing helicopter dock, commonly abbreviated as LHD. An LHD is a warship that integrates a full-length aviation flight deck with a lower well deck capable of launching amphibious landing craft. During the early 2000s, a major debate took place inside Australian defense circles regarding what type of amphibious warship the nation should buy. Some analysts favored smaller landing platform dock ships, which focus primarily on waterborne landing craft and carry fewer helicopters. Others advocated for pure helicopter carriers. The hybrid LHD design ultimately won the debate because it combined heavy air assault with heavy surface transport. A single LHD could serve as a complete offshore command and logistics hub, giving commanders the freedom to launch troops by air, sea, or both simultaneously. Australia formally launched Project JP2048 to acquire two new amphibious ships. Two major international shipbuilders competed for the contract. French shipbuilder DCN proposed an enlarged variant of its proven Mistral-class design. Spanish shipbuilder Naval offered a design based on a strategic projection ship, built for the Spanish Navy as the Juan Carlos I LHD design. In 2007, the Australian government selected the Spanish design. Construction was split across continents. Naval built the steel hulls at its shipyard in Ferrol, Spain. The hulls were then transported by heavy transport ships to Melbourne, Australia, where BAE Systems Australia completed the superstructure integration, combat system installation, and final fitting out. The Canberra commissioned into service in 2014, followed by the Adelaide in 2015. At full load, a Canberra-class vessel displaces 27,500 tons, making them the largest warships ever operated by the Royal Australian Navy. Despite this displacement, naval architects designed the hull with a maximum draft of just 7 meters. Keeping the draft low was a strict requirement for operations in littoral environments. A shallow draft allows these large ships to navigate undredged regional harbors, across small island anchorages, and operates close to shorelines where deeper United States Navy capital ships cannot go. To drive this LHD efficiently, engineers chose a combined diesel and gas turbine propulsion arrangement. The machinery layout consists of a single General Electric LM2500 gas turbine operating 19.1 megawatts, alongside two Naval MAN diesel generators providing 7.4 megawatts each. Electrical power generated by these engines powers two 11 megawatts azimuth thrusters mounted in pods beneath the stern. Combined diesel and gas electric propulsion provides high fuel efficiency at economic cruising speeds of 15 knots under diesel power, while reserving the gas turbine for higher speeds above 20 knots. The rotatable stern pods, paired with two bow thrusters, allow the ship to turn within its own length and dock in tight ports without tugboat assistance. Together with the shallow draft, the propulsion configuration and the azimuth thrusters make the ship highly flexible for operating in the confined littorals of many Pacific islands, while maintaining the ability to traverse the vast distances between the islands within reasonable timeframes. The primary combat power of the Canberra class lies in its amphibious sea lift capacity and conduct of opposed landings. The internal structure features over 2,400 square meters of vehicle deck space divided across heavy and light vehicle decks. These decks accommodate up to 110 vehicles, including light armored vehicles and protected mobility vehicles like the Bushmaster and the Hawkeye, and of course heavy armor like main battle tanks. At the stern, a flooded well dock holds four Spanish-designed LCM-1E landing craft. These landing craft can transfer heavy tanks and cargo from the ship directly onto the beaches. For troop transport, each vessel provides accommodation for 1,050 embarked troops under standard conditions, with overload capacity expanding to 1,600 personnel for short missions. To turn this transport capacity into a fighting force, the Australian Defence Force restructured its amphibious warfare forces around the ships. The Australian Army designated the 2nd Battalion, Royal Australian Regiment, as a specialised amphibious light infantry battalion. The 2nd Battalion forms the ground combat elements of Australia's amphibious ready element. When deployed with artillery, combat engineers, medics, and logistics units, this force forms an amphibious task group. The Canberra class provides this task group with a fully self-sustaining mobile base, complete with advanced command facilities and a small hospital with 2 operating theatres. Aviation operations take place on a massive flight deck measuring 202 meters long and 32 meters wide. The flight deck features 6 marked helicopter positions, allowing 6 medium-sized helicopters to launch or land simultaneously. Alternatively, 4 landing spots can support heavy-lift rotary aircraft, like the Boeing Chinook. Directly beneath the flight deck sits a 990 square meter hangar deck that holds 8 helicopters in a standard operational layout, or up to 18 helicopters if space is maximized and if some of the vehicle space is used. The standard air wing includes a mix of MH-60R Seahawk anti-submarine warfare helicopters, other utility helicopters, and armed reconnaissance helicopters like the Eurocopter Tiger or Boeing AH-64E Apache. The most distinctive feature on the Canberra class is arguably the 13-degree ski jump ramp located at the bow. This ramp is a residual element left from the Spanish Juan Carlos I design. Spain built its vessel to launch short takeoff and vertical landing or STOVL fighter jets, such as the AV-8B Harrier II. During the tender evaluation, Australian engineers considered removing the ski jump to extend the usable flight deck. However, detailed structural analysis showed that modifying the bow section would require a complete redesign of the forward steel structure to maintain balance and stability. Modifying the bow would change the ship's center of gravity, alter its weight distribution, add financial cost, and delay ship delivery by several years. Retaining the ski jump was simply the cheapest, easiest, and lowest risk engineering solution. The presence of the ski jump fueled persistent debates in Australian naval circles over whether the Navy should buy the F-35B Lightning II STOVL fighter from the United States. Formal government reviews repeatedly rejected this idea. Buying F-35B fighters would require expensive modifications to the ships. Operating the F-35Bs would take far more than just the ski jumps. The flight deck surface would need special heat-resistant coatings to survive the intense vertical blast of the F-35B engine during landings. The ships would also require larger aviation fuel tanks, expanded weapon storage, and jet maintenance facilities. More importantly, embarking fixed-wing fighters would disrupt the ship's primary mission, which is amphibious warfare. Storing jet fuel, air-to-air missiles, and heavy maintenance equipment for STOVL fighters would reduce the space available for Army transport helicopters, landing craft, and troops. Without supporting assets like airborne early warning aircraft or air-to-air refueling platforms, a small air wing of 4 to 5 fighters would offer very little combat power while severely degrading the ship's ability to land ground troops. Australia opted instead to rely on the Royal Australian Air Force's conventional F-35A fighters operating from land bases. The Canberra-class LHDs are not do-everything ships. They are amphibious warfare ships first and foremost. Although the F-35B concept was rejected, the physical foundation remains. Should Australia's strategic environment change materially in the future, the option provided by the ski jump leaves open the long-term option to modify the Canberra class for fixed-wing jet operations. The Canberra class transformed Australia from a nation with limited sea lift capability into a significant amphibious power in the South Pacific. By pairing heavy vehicle transport and landing craft with sea-based aviation, the Canberra and the Adelaide provide Australia with an adaptable tool for maritime defense, regional intervention, and humanitarian crisis response.